Hi, in the previous video, we went through the process of creating in just 2 or 3 lines of code a database and then filling it out with a pandas data frame. So again, this code is being pulled from exactly that video. So check out the video if you want to go in more detail. In this video, I specifically want to uh, go through the detail around this df to SQL method. This is a very important method which can be used over and over again to store data in a SQLite3 database. So it's important that we understand how this method works, what are the outcomes, and how we can control the outcomes better. So let's dive straight in. As you can see, the one of the options, so df to SQL method, the first bit here is the table name, which would be created. Con here is the connection. So all this is doing is connecting to a test database, which will have an average grades table. And if exist method in it, the option here is set to replace. What it means is if this table exists, it's going to replace that with a new table and reset the table. So I have already created this table. So let's first look at how the table looks like in its current state. As I mentioned in my previous video, I use this very simple free to use software DB browser to visualize the database. It's extremely helpful. So if you want to use it, just download and visualize your database quite quickly. Now you can see the data is in here. We have the data in the table, and you can see that the maximum rows in it are 27 rows in the table itself. And another thing, as it currently stands, I want to show you is that it has automatically assigned uh, column attributes, like what are the data types for each of the column. For example, we can see that class is an integer, section is text, number of students integer, and grades is text. So it automatically does that for you. It's very important to note that, because then you know that there are some things which are automatically being influenced. So if you have to control it, we'll go through how we can control it through this video. And also what it's doing, it's created an average, it created an index on average grades. Again, it did it out of the box. There is no control here, and we want to control that as well, because putting an index in your database is extremely important for data retrieval. Otherwise, your database would be can slow down massively. So I would highly encourage using an index wherever there is a possibility to do that. So first thing I think I want to do is to uh, show how this if exists replace a bit of the df to SQL method works. Again, let me show another thing. The data we had in the database goes to 27 lines. Now, what happens if I change the if exist statement to append? So what this append method would do is it would assume that a table exists and then append this data below the existing data. So literally doubling that. So I have run this code. Let's see how the data looks like. And no surprise here, as you can see, the data has literally been doubled. So I've got 56, and before it was half of that. So important thing to note while using the database. Now, what replace does, if I use replace again, so you will see the data will be cut down to half again. So let's go back into the database, and no surprises, max is to that number we just seen. Uh, However, there is a catch. When you use replace it, if you have created or custom created any bits on your database, and what I mean by that is that if you have created any foreign key constraints, or if you have created primary keys, a replace method is just gonna wipe it off and start over again. So if you are using the same database over and over again, and you have put some foreign key constraint, the structuring in your database, then I would encourage using append, because with an append, you can delete the data if you are replacing anything with a separate SQL command, and then append, which would mean you are not deleting the table stays intact. So that's a pretty important one. The other bit is I've just mentioned around this index bit. So we have no control over this index. So we can get control over this by essentially using another built-in method where we can specify index label will be the ID, and I'm still keeping replace so that we are not duplicating the data in the database here. So here we're referring to this ID column to be the index. So let's run this and see how it changes. I'm gonna just focus on, so this is where this DB viewer is telling us where the index currently sits. Let's run our code and come back to it and see what happens. So we run our code, we go back into the database, we need to refresh the data, and you can see now it's moved to uh, ID as the index rather than what we had before. Right. And then I think the last bit is you can also then control the data type, and I've already written this bit in it. So data type essentially has to be a dictionary. We have got this dictionary called column data types, which is referred here. And as you can see in here, I've got class as a text, whereas this is showing that class is an integer, which has been picked up by default. So if I run this code now, where I'm calling the data type, which is column types, which in here we're saying class is text, we should see text there as well. So let's go back, refresh, and you can see now class is text. So what is very important takeaway from this video is, whilst you're using the df to SQL function, it's extremely handy for data scientists or analysts to use. But you should be able to control how you manage your data coming into the database and have awareness of it. Without having this level of control, you won't be able to control the behavior of the SQLite database. With this, I'll end the video here, but if you wanted to see the introductory video, please see the link in the description, and I've also done another video of how you can connect this database essentially to Excel, and I'll Excel or the Microsoft product. So I'll put another link in the video, in the description as well.